Okay, welcome back. And so today we're going to do another example, and this one here involves finding the antiderivative of this function here. Okay, so the first thing I'm going to do is to find the antiderivative is I'm going to rewrite this. So we want to find the antiderivative, so we're going to integral, and I'm going to rewrite this as e to the x, and I'm going to write this as with an exponent, okay? So this is going to be 1 plus e to the x dx, because I'm writing as integral. Now, before I get started, not that it has anything to do with this, but something I thought of that I want to tell you, so pay attention. One of the common mistakes that students make is they mistake this e to the x as like the same as a polynomial, and it's not. Okay, we can't use the power rule here, okay, because it's not a polynomial function. Okay, and what even makes it more confusing is when we have e to the x, we have exponentials mixed in with polynomial functions. It makes it confusing for students, but you just got to make sure that you check your work and you're careful about your work. Okay, I can't tell you enough the biggest mistakes that students make, even me. If I make a mistake, it's going to be in the simple stuff. Okay, so you got to make sure you double check your work and be careful. Okay. Okay, so going on. So this is going to be written as 1/2. Okay, so now I'm going to do a u substitution. Why? Because I've got this e to the x out here, and I've got this e to the x in here, and we know that the derivative of e to the x is e to the x, right? And so let's do that. So I'm going to make u equal to e to the x, and then of course du will equal e to the x dx. So now I can just do my substitution here, so it will be, oh, hold on, e to the x plus 1, that's what I want. So now it just becomes u to the 1/2 du. And we know how to handle that, right? So then this just becomes 2 oh, it's not 2. Almost made a mistake. So this is going to be that, right? Just using the power rule. So remember, instead of divide, remember you're increase the power by 1, so it becomes 3/2, and then divide by the new power, or in other words, multiply by the reciprocal of its fraction. So I just multiplied by 2/3. Now, we're not done. We have to now put it back in terms of x. So now our final answer becomes 2/3, and u is e to the x plus 1 to the 3/2 power plus c. And that is our answer. Not bad, huh? I mean, it's pretty straightforward. A lot of these just take practice and seeing what you're doing. And the thing is, even if you get a complicated one, and they will get more complicated, trust me, you've just got to make sure that you look at the problem. And the thing is guys, you've got to do a whole bunch of these. Especially when we get to integration by parts and we get to partial fractions, things like that. The key to being good at doing these is to do as many as you can, because what happens is you start to observe and you start to recognize certain things, okay? And then you start to see, hey, certain situations you try this, and you start to recognize when I should do certain techniques, okay? So anyway, so let's do this one. So here's another one for you to try on your own. So try this one. Find the antiderivative of this expression here. Okay, so that's the expression. I want you to find the antiderivative of that expression and then see if you get the right answer. Okay, have a great day. I'll see you next time.